everyone, welcome to KA Academy. Um, I wanted us to go through uh, chapter 4 and 5, but it actually deals or helps us to understand better the ladder logic and some usage of PLC. So we can just scroll through in a way, and so that we can. I wanted us to do this example where we would be having an actuator to fill this tank, and then so we'll be having a sensor that will be measuring the level within this tank in order to open and close the actuator to fill. So we'll be filling this actuator this tank in this exercise that I want us to do. So we're gonna do analog input, so that would be for the reading, and for us to operate the actuator, we'll be just using digital uh, signal to open and close. Um, we're not gonna do positioning and half close, half open, but something like that. So we're gonna do full open, full close. So we'll open if the tank is like at 20%, and then we're gonna close the actuator when the tank reaches um, what do you call 80%, for instance. So in that example, we'll be dealing with we'll have to do scaling of the variable in terms of the analog, and then we're gonna do a control of this digital signal using the set points that we would have agreed upon in here. So what we are saying here is at 80% we close, and then at 20% we open. Okay? So from here we'll be getting whatever signal. If we agree, we can say 4 to 20 milliamp. And then here would be just doing a digital signal here, DI, this one, open and close. So this is the example that I want us to go through. So without any waste of time, we're gonna call it feeling. Feeling. So without any waste of time, I guess we'll deal with the chapter 4 and 5 of timers. So we will be using a few of the things that are in this, the normally open, normally close, which we've been doing. We have what you call counters in this. You can count up or down. You see a counter with a CTU or a timer TON. That means this is an on delay timer. And then there's TOF, which is delay off. There's TP. So we'll be dealing with those. Of delay timer on delay timer, off delay timer, retentive timer, which means it retains the elapsed time even if the timer is interrupted. And then we're gonna have a counter up and counter down, and then the different types of the signals, 40 to 20 milliamps there, 0 to 10. This is analog signal processing. This is what we'll be dealing with in that example up to here, up to 5.2, and then we will do data manipulation and whatever, and the rest later on. So without any waste of time, let's dive into it. Let's open our program. Yeah, without any waste of time, we're gonna open our folder, and then in the next video we will do the practical of the theory that we just browsed through. Thank you, and remember to subscribe to this channel. Thank you very much.